All right, next topic, we are going to continue talking about linear equations like we did in the previous chapter, but now our linear equations are going to have two variables instead of one. So again, I'm just going to try to tap into some stuff that you already know, so hopefully you have a super feeling of confidence as we go and we talk about graphing and we increase that. So there are two things that you need to know to be able to graph. I'm going to teach you both those things, then we're going to combine them together and hopefully have a great experience here. So before we do that, just want to introduce you to our good friend. This is the Cartesian plane, and I've cut and pasted Cartesian plane on there. The Cartesian plane is so named from a French mathematician named René Descartes. And the story goes, because there's always a fun story in math, René Descartes was a very, very lazy man. He liked to just lay in bed and do nothing, because who doesn't, right? But this was before Snapchat or Instagram, because he lived hundreds of years ago. So how he passed his time was thinking and looking at his ceiling. And on the ceiling, he saw a bug walking because he didn't have the pest control guy come. And so as a mathematician, his initial thought was, how could I describe the movement of that bug on the ceiling to someone? So math starts in weird ways. And so René Descartes had the thought of, let's create this grid so that I can label the points on my ceiling to describe the movement. So it's called the Cartesian plane. If you don't like that name for it, it's also called the rectangular coordinate system. It's called that because our two axes that we're going to meet in just a minute, they intersect at right angles. And there are other coordinate systems. So as you progress further in math, beyond college algebra, and you're into pre-calculus, get to calculus, you'll encounter something called the polar coordinate system, which is concentric circles that you graph on. There's also, I forget the name of it, it's named after a Russian mathematician, but there's a coordinate system that's on a globe. Where you can have triangles with more than one right angle. So math is fun, and there's lots of stuff beyond this. So you're learning the basics, so hopefully someday you can have exciting moments with other things. So as I mentioned, we've got these two darker lines right here. They are called our axes. And so this one right here, the one that goes left and right, is called the x-axis. The one that goes up and down is called the y-axis. When you get to the point where you talk about three-dimensional space, you'll have an axis that comes out of the paper, and it's called the z-axis, but that's beyond our scope in this class. In this class, we'll always use x and y. I'm not going to change the letters, so there's not going to be anything, any tricks or gimmicks. So you notice that the axes divide our Cartesian plane into four parts. Each part is called a quadrant. And the way that they are labeled in any class, whether you're in physics class or math class or an economics class, the quadrants are always labeled the same. They go in counterclockwise order. This is called quadrant 1. And so math people are always clever with labels. That's quadrant 2. Here's quadrant 3. And finally, quadrant 4. Those are the four quadrants. So if you want to tell me a point is in a particular quadrant, so if it's down here, you'd say, okay, this point's in quadrant 4. The other thing I just want to mention to you is where the x-axis and y-axis intersect. That is called our origin. The reason it's called the origin is in a moment when we review plotting points, that's where we originate. We start at the origin, and our directions will take us to a particular point that adheres to that label. Now, how do I get that to that particular point? That's a great question. So all points are labeled using what's called an ordered pair. An ordered pair is so named because order matters. It's like the Google address for any point that's on the Cartesian plane. So any point you read, and again, I'm 99% positive all of you have seen this and are bored right now because you know all this. Our ordered pair always has the x first and then the y second. Okay, so the x-axis is first, the y-axis is second, and that tells you how to get to your destination point. So that's just a real quick overview of our Cartesian plane. And so now what we're going to do is review the idea of plotting a point. So I told you that there were two things you need to know how to do to graph a line in the most basic way possible. When we come back next time, we'll talk about a little bit more advanced way to graph a line. But the first thing that you need to know how to do is to plot a point. So hopefully you're like, oh, this is great. I can do this. So we're going to graph the following ordered pairs. Okay. So the first one, notice I've given each of the ordered paired names so that we can label them on the Cartesian plane so we know which one's where. The first one's 3 and 5. So here I'm at my origin. I'm not going to make a dot at the origin, but which way am I going to go first? I'm going to go to the right, 3 units. That's the x direction. So 1, 2, 3. And then I'm going to go which way? Up, 1, 2, 3. Notice I'm not trying to trick you. I've even given you Cartesian planes that have labels on them and tell you which way the positive and negative direction is. These are the same Cartesian planes that'll be on the test that you take in my class. Okay, so there's going to be no differences. So that is point A right there. Point B, I'm going to go back to the origin, is -4 and -1. So the -4 tells me to go where? Left. So 1, 2, 3, 4. And then -1 is down 1. So there's point B. And last but not least, our point C is 0, 3. So the 0 being in the x position, what does the 0 tell me to do? You don't go anywhere, right? You stay right there. And so then I follow the directions of the 3 and I just go up 3. And there is my third point C. Not expecting any, but if you have one, by all means, any problems locating a point on the Cartesian plane? All right, well then do me this favor. I'm going to give you 30 seconds or so. At the top of the next column is exercise 1. If you would please graph those 4 points and label them. Check your work with my work. If you got something different, I mean, it's easy to make a silly little mistake, and those happen. But if you made a mistake and you don't know why, let's talk about it. So the next point is 5, -2. So that means I'm going to go right 5, and then I'm going to drop down 2. So there's my point D. It's in quadrant 4. My point E is -6 and then up 8. So that's 5, 6, 7, 8 right there. So that is point E. It's in the second quadrant. The next one, F, is 4, 0. So I go in the X direction 4, and then I don't go anywhere in the Y direction. So F is on the boundary between quadrants 1 and 4. And last but not least, G is -4 and -5. So -4 is left 4, -5 is down 5. And so there is point G. Okay. We all comfortable graphing points? We good? Okay, great. That's 50% of graphing a line. You're almost there. Great job. So before we do that, before we turn the page, what we have now is what's called a linear equation of 2 variables. Okay, this is the linear equation. This is going to represent a relationship between our 2 variables. In this case, it's going to be x and a y. So the equation is just going to give us a relationship between the 2 variables. Oops, I already wrote the word between. And so a linear equation of 2 variables can be written in this format right here, where I have some number, a coefficient, it can be any real number in front of my x, plus some real number, it can be any number at all in front of my y, is equal to a number. And when you have your linear equation written in this format, where the x and the y are on the same side of the equation, this form is called the standard form of a linear equation. We're going to encounter a couple other forms as we go through this chapter the next few days. Okay, so the standard form is when you have the x and the y on the left side, or they can be on the right, but on one side, and then the constant is on the other side. So here's what we're going to do. This is the other 50% of being able to graph a line. So we're going to look at example 2. In example 2, I've given you a linear equation of 2 variables, 2x plus 3y equals 6. Okay, that defines the relationship between that x and y. And so what we're going to do, I'm going to do the first one, and then I'm going to let you do the next 2, is we're going to fill in the missing value. Meaning, if x is 0, what is the y value that's related to it according to this this equation. Okay, so yes, you're good at arithmetic. I appreciate that. So what I'm going to do is I'm going to take the 0. I'm going to plug it in for x. Okay, so I understand that the numbers are pretty simple here, and some of you, you've done this in your head. That's beautiful. I love that. Okay, but not everyone is there, so I'm just going to write this out real quick. So I've got 2 times 0 plus 3y is 6. Anything times 0 is 0. It's my favorite number to plug in. So then I get 3y equals 6. And then when I divide both sides by 3, as we learned to do last week, I've got y equals 2. So the y value indeed is 2. So thank you for whoever provided that. I was not ignoring you. I appreciate the knowledge. Okay, so what I would like you to do is the same thing. I've given you a y value in the second row and then an x value in the third. If you would please define the missing value for each of those. All right, so this is just a substitution problem. You're going to do it 2 different times. If you're still working, keep working. We'll check our work. I'm just going to get started. So the next row, I'm going to put in -4 for the y value. So I've got 2x plus 3 times -4 is equal to 6. Okay, so notice I've taken the -4 that was in the y column. I've put it in here in the position for y, in case you're wondering what I did. So then I have 2x. 3 times -4 is -12. And we spent a couple days last week talking about solving things. So you've already got this skill, and you all said you don't really have many questions about that. So I'm just going to roll through it. So I have 2x is equal to 18, divide both sides by 2, and I get that the x value that is related to the y value -4 is 9. So I've got 9 comma -4 right there. Anybody get something different and does not see why you messed up or how that's so? Remember, you get out of this class what you put into it. So if you're sitting there and you're confused, then I don't want you to be in that state. So ask a question. I can't ask them for you, but I can hopefully answer them. I'm going to do the same thing with the x value -3. So I'm going to take 2 times the -3, okay, plus 3y is equal to 6. The 2 times -3 is -6. I'm going to add the 6. I'm seeing that I probably should have left a little more room for the work here, so sorry about that. And so then I've got 3y is equal to 12, and when I divide, I get y is equal to 4. Okay, a little bit of a mess there. So now I've got a table of values, and we're going to come back in a minute. We're going to do something. So that's the second skill. The first skill to graph a line is being able to plot a point. The second skill to graphing a line is being able to find the value that is related, to do a little substitution. So what I would like you to do, just so that you get a little confidence doing that, is exercise 2. I've given a different linear relationship. If you would please go ahead and fill in the missing values. All right, so I know everybody works at different speeds, so I'm not trying to rush you if you're not quite done, and I'm not trying to bore any of you that are done. So let's get started with this. Check your work with my work. I'm first going to put 0 in for x. So I have 2 times 0 minus y is 4. 0, again, is my favorite number to plug in because anything times 0 is 0. So I just have negative y is 4. And when I divide by negative 1, I get y is equal to negative 4. So there is my first value, negative 4. If I mess up or if you get something different, let me know. I'm just going to keep rolling along. My y value is going to be 4 this time. So I'm going to put 2x minus, when I put the y value of 4 in, this is a positive 4. That minus sign is part of my linear equation. So it's going to be 2x minus 4 is equal to 4. I'm going to add the 4 to both sides. Okay, again, we talked about the solving. I'm hoping the solving is not the stumbling point here. Divide by 2, and you get the x values 4. Oops, 4. Sorry, it said 4, wrote 2 for some reason. And then last but not least, I'm going to put the x value 3 in. So I get 2 times 3 minus y is equal to 4. 2 times 3 is 6. Subtract the 6 from both sides, and I get negative y is equal to negative 2. And divide by negative 1, and y is positive 2. And I did a little better with my space that time. Any questions before I move on? You're doing okay with doing some substitution? Okay. Well, now let's just combine those two things, and we're going to graph the line now. So I'm going to do example 3 right below. So we've done the substitution. We've done what would be the hard part to this problem. We have found 3 points on this line. Now I'm going to graph them and I'm going to connect the dots. So here we go. My first point is 0, 2. So that's the x value 0, the y value is 2. So that's this point right here. The next one is 9, negative 4. So I go over the x direction 9. So 5, 6, 7, 8, 9. And then down 4, 1, 2, 3, 4. And then last but not least, negative 3, 4. So left 3 and then up 4. I get 3 dots. My dots should form a line. If they curve at all, you have miscounted or miscalculated. Okay, so whoops, I don't want you to see my driver's license photo. So we'll just use this side right here. And there we go. So not too bad when you break it down into its 2 component parts. So real quick, exercise 3 is to take the 3 points that we just found over there and to plot them and connect the dots. Put some arrows on the end so that everybody knows that the lines go forever in both directions. They don't stop. That would be a segment. That's a completely different thing. So my first point is 0 and negative 4. So I go down 4, I make a dot right there and be really happy and proud of it. The next one is 4, 4. So the x value is 4 and then the y value is 4. So make a nice dot there. And then 3 and 2, nice dot there. Again, when I put my straight edge right up to it, everything should line up perfectly. Oh, it does. This is the line of the year. So here we go. Woohoo! And there's my line. So before we go on to the next problem, okay, and we each do another one, here's something I want to point out to you, okay, because I want to streamline the process a little bit. I'm not trying to torture you with all sorts of arithmetic here. So what we're gonna notice here is that there are a couple of significant points. I've already told you I like to plug in 0. So we see right here that one of the points we plotted was this point right here, 0, negative 4. This point right here where the graph goes through the y-axis, that's called the y-intercept. The reason I point it out to you is, and you can go back up to the table right above to answer this question, what is always going to be the x value of your y-intercept? Yeah, the x value is 0. Because any point along the y-axis has an x value of 0. You've not gone left or right at all. So that's why the x value is always 0. Now, this was not one of the points we plotted, but it's also included in the graph because the graph, the reason we do this is the graph represents every possible point, every possible relationship. So this point right here, where the graph goes through the x-axis, math people are clever, it's called the x-intercept. Now, we did not have this in our table up above, but I'm hoping you can hypothesize for me. What would be true about the y value of any x-intercept? 0, because I've not gone up or down at all, right? Does that seem reasonable? Okay, so the x-intercept, the y value is 0. So we're going to take advantage of that, hopefully, and the fact that plugging 0 into an equation is a nice, quick thing to do. And we're going to, in example 4, we're going to graph the next linear equation using the intercepts. Okay, so I'm going to slide this up. So I'm going to make a quick little table. And my x-intercept happens when the y value is 0. So that's my x-intercept. I'm going to abbreviate so I don't mess up the next Cartesian plane. And then the y-intercept happens when x is 0. And I'm just going to figure out what those two values are. Now, I know you're going to do, you probably already can do this. The nice thing about plugging 0 is you can use your finger to, you don't even have to do a whole lot of writing down. So when I put in the y value 0, I'll write this down in a minute because I want to be a good professor. I want you to give me good evaluations. But when I put the y value of 0 in, notice I can just cover up 4 times y is going to be 4 times 0. So you're going to get the x value of what? 4. Okay. In case you don't see where that came from because I went so super fast, the y value is 0, so I get 2x plus 4 times 0 is equal to 8. 4 times 0 is 0, so 2x equals 8. And then x is the aforementioned 4. For the y-intercept, we do the same thing, except this time we put 0 in for x. And again, you can just use your finger. When you put 0 in for x, that makes this term here disappear. And you have positive 4y equals 8. So that means the y value is going to be what? 2. And again, in case you're not quite on solid ground as some others, that's totally all right. We all learn at different paces, so don't judge yourself. So I'm going to put 0 in for x. So we've got 2 times 0 plus 4y equals 8. 2 times 0 is 0. And when I divide by 4, that's where the 2 came from. So there's my 2 points. Hopefully we can get those pretty quickly and easily because I don't want graphing a line to be too bad of a deal. So I've got the x-intercept of 4, 0. I've got the y-intercept of 0, 2. If you really wanted to, a third point is never a bad idea to check your work. But when you're doing your homework in my math lab, they do not require a third point. So I'm not going to require one either. So there we go. There's our line. It's beautiful. Just like that. If you got a question, ask it. If not, go to exercise 4. If you're too shy to ask your question, raise your hand. I'll come to you while we're working on this problem and see if I can answer it. Graph this using the intercepts, please. Another 30 seconds or so. Make your best attempt at this. Remember, the reason I have you do problems, just to give you an opportunity to ask your questions, okay? So that's why we're doing this. You get some instant feedback on how much you understand. I'm going to plug 0 in for y first. Again, I know some of you can do this quicker than others, and that is great. For something like the whole point of the intercept method is to make this nice and quick. So I've got 3x minus 2 times 0 equals 6. 2 times 0 is 0, so 3x equals 6. And when I divide, I get x is equal to 2. So there's my x-intercept is 2, 0. My y-intercept, I'm going to put 0 in for x. So 3 times 0 minus 2y equals 6. Please remember, this is probably the most common mistake I'll get on the test, is just getting sloppy with the signs. Don't forget that that minus goes with the 2y. Don't just leave it off. Sometimes we work fast and forget that. So now I divide both sides by the -2, and I get y is -3. That's my y-intercept. So the x-intercept 2, 0. The y-intercept 0, -3. There we go. And then I take my straight edge and I confidently connect those dots because I'm so happy to be in Mr. Perkins' algebra class today. Yes, exactly. You should get. All right, we're going to flip the page. Just going to have you do this a couple more times because that's really the essence of the section. So go ahead and do exercise 5. Graph that using the intercepts. All right, I'm going to get started. Again, check your work with my work. I've got my table set up, my x-intercept, my y-intercept. So I'm going to plug in the y value 0, and I get -3x plus 8 times 0 is 24. That becomes -3x equals 24. And when I divide, I get x is -8. That's fantastic. So I'll put a -8 right there. And then when I plug in 0 for x, I get -3 times 0 plus 8y is 24. And then that becomes 8y is 24. And when I divide by 8, I get that the y value is 3. So there's my x-intercept, my y-intercept. The x-intercept's -8. So -5, 6, 7, 8 right there. 0, 3, up 3. And so here is my line. Your line and my line should be identical. If yours is going in a different direction, that means you had a problem with your signs. So just make sure that you're doing everything the way that you should. One more very straightforward graph using the intercepts problem. So do exercise 6 right below it, please. All right, so again, I'm going to get started. So when I plug in 0 for y, in order to find my x-intercept, I get 6x plus 4 times 0 is 12. That becomes 6x equals 12. And so you all probably have written on your paper that x is 2. And then the same thing, I'm going to plug in 0 for x in order to get the y-intercept. So that becomes 4y equals 12. So the y value is equal to 3. So there we go. So 2, 0 and 0, 4. So here's my first one, 2, 0, 0, 4 is this one. So again, your intercepts and mine, we should all be staring at the same values. Our lines should be shaped the same. There we go. Yes, exactly. That's what I said. Y equals 3. And then I wrote 4 because I'm a doofus. So good job, Perkster. And I'm filming this one. So now this mistake is caught eternally. Let me use a different color. So here, the red one's actually the right one. Sorry, everybody. Yes, sometimes I'm confident in my mistakes. I guess that's sort of a good thing. Who knows? All right, the red one's the correct one. So if you're watching this on video 5 years from now, I apologize, but that's what you get. All right. Any other questions or mistakes that I've made? I'm good for 1 or 2 good mistakes a class. I'm just making sure you're awake. All right, so do exercise 7. Graph that using the intercepts, please. All right, so let's give this one a try. I do have a reason for this problem. So if you encountered any difficulty, that's okay. So when I do my x and my y, and I go to do my x-intercept and I plug in 0 for y, and I go to do my y-intercept and I plug in 0 for x, here's what happens. I put my 0 in for y and I get 0 is equal to 3x. And so then what is the x value? 0. So here's what happens on this problem. And this is the reason I gave it. And then I need to show you what to do. The x-intercept and the y-intercept are the same point. It's the origin. The reason this happens is because in this linear equation, there is no constant term. There's no constant term. So when that happens, that means the linear equation is going to go through the origin. And so it's not super helpful to just have one intercept, because which way does my line go? So the quick and easy way to resolve this is just to pick a point or two, pick an x value. So I'm just going to come down here. I'm going to pick an x value. You can pick any x value you want. There's no limitation. X can take on any value. So I'm just going to pick the value 3. Okay, so I'm going to put in the x value 3 in my table up there. When I pick the x value 3, I get y is equal to 3 times 3. So you likely, because you are a different person, you likely picked a different value, and that's fine. We all have the same line. So I've got the x value 3 and then up 9. So that's right up here. And so just here's the thing to notice about that. If you picked the x value 1, then you got the y value 3. And notice your point is on my line, just like my point's on your line, because a line represents all the possible ordered pairs. If you picked the x value 2, 2 times 3 is 6. So that is 1, 2, 3, 4, 5, 6. Notice the point you picked is on my line. Okay, so even if you picked a different x value, we have the same line. Okay, so that is going to be totally fine. All right, before we move on, any questions about that or any of the other problems that we've done? Just wanted to show you what to do when you have an x and a y variable, but you don't have a constant term. And so now on our last page, we're going to talk about a slightly different situation. So notice in example 5, I've got the equation y is equal to 3. What is different about this equation versus any of the other equations we have graphed?
No x.
There's no x. Okay, so what do I do when there's no x variable? Well, let's make a little table and we'll see what happens. Now, I'm going to recommend after we see what happens that you just remember the situation because it's going to pop up in a bunch of different sections. So if you just remember the difference between these two lines that are on the last page. So I'm going to make a little XY table here. And what this line says is no matter what, the y value's 3. So if I pick the x value 0, what's the y value that's going to be with it? 3. If I pick the x value 8, what's the y value that's going to be with it?
3.
Any x value you pick. So -1, last one, what's the y value going to be?
3.
For sure. The y value never varies. Okay. So let's plot those points and see what their relationship is. So I've got 0, 3, that's this point. I've got 5, 6, 7, 8, 3. I've got -1, 3. And when I connect these dots, I know this is a straight line, so I'm going to pull off the board the answer I'm not looking for. What kind of straight line is this? Anybody know what this is called? Yes, horizontal like the horizon. Okay, this is a horizontal line. Anytime you have an equation that is missing the x variable, that is a horizontal line. Now, I just want to point out something because sometimes you link things in your brain that are not to link. We'll come back to this, don't worry, but I want to flip back to the previous page. Why is this one right here not a horizontal line? It looks really similar because there's an x and a y. Okay, so if you have the x and the y, it's not going to be a horizontal line. So notice the difference. Sometimes students can conflate those two, and if you have an x and a y with no constant, make it a horizontal line. I'm going the wrong direction in the notes. Here we go. Ah, there it is. So anytime you have an equation that is y equal to a number, it is a horizontal line through that number. So whether or not you need to draw a table, in exercise 8, I've asked you to graph 2 horizontal lines. So go ahead and graph them for me, please. Okay, these are 2 separate lines, just in case you're confused. Okay, so you're going to have 2 lines on the Cartesian plane. Just wanted you to practice, that's all. Again, what I'm hoping for is that you will say, oh, hey, this is a line. There is no x equation, so that's horizontal. Okay, that would be convenient if you can remember that. If not, you can always make a table. So the first one is the horizontal line with all the y values -2. So here is the y value -2, and I'm going to draw a horizontal line. So this one right here, that is green on my page. This is the line y equals -2. Then the next line, separate problem, y equals 7. Again, there's no x variable. So it's going to be a horizontal line. So it's going to be a horizontal line with the y value 7. So here's my y-axis. Here's my y value of 7. And I'm going to draw a horizontal line. So this line that I'm drawing, that's pink. If I want to make sure that I do the best possible job I can. There it is. Beautiful. That is y equals 7. Questions about that? All right, well, here we go. We're almost done with section 2.1. That's the problem with me making worksheets, is now I do not know how long class takes. So this one's going to get done earlier. I will do better. Don't worry, I'll adapt. You'll get your money's worth out of this class. Okay, so this next one says x equal to 2. So I'm going to make a little xy table for this one, and then we're going to see what happens. And so notice what's missing out of this equation. Okay, there's no y variable. So this equation says no matter what is the only x value I can pick? 2. So the x value is 2, so then the y value can be anything. I'm going to say 2, 5, 2, 0, 2, -7, 2, whatever. You can pick any points you want. 2, 2, sure, let's do it. So the x value always has to be 2. So here we go. So the x value is 2, and then I've got y value 5. X value is 2, y value is 0. X value is 2, y value is -7. And then x value is 2, y value is 2. Now, why connect these dots? What is this kind of line called? It's called a vertical line, yes. Straight up and down. When we come back next time, we're going to have some fun trivia about horizontal and vertical lines. So look forward to it. So don't pack up yet. It's still early. Don't be that excited to leave. Do exercise 9. Please graph both of those lines on the Cartesian plane for me. So again, the thought process that I'm hoping you will adopt is you'll see these equations and you'll say, oh, there's no y variable. That's a vertical line. Okay, so the first one is a vertical line at the x value 5. So here's the x value 5. So I'm going to draw my vertical line through that. So that one is x equal to 5. And then the second one is, again, is missing the y variable. So that is x equal to -8. So here is the x value -8 way over here on the other end of the Cartesian plane. And then I will put this in orange, and it looks like this.